So here we are. So first of all, if you'd like to work with Jamovi first, it's necessary to download it. It is available online for free, so that's no big problem. If you run it for the first time, you would see this environment, which seems quite simply. Only, I would like to say that if you install Jamovi for the first time, you will see only exploration, t-test, Anova, regression, and frequencies and factor. All the rest are some edit modules that I'm using, so you will not see these modules. And if you like to open data file in Jamovi environment, that's very easy. You would visit this left upper corner with these three white lines. If you click by left button, you can select open. And then you can try to find the destination of your file. And what is very pleasant is the Jamovi is very, very flexible in opening data files. So it can open data file from text formatted data, which is maybe the most general. It can open data from Microsoft Excel format, but as it is also designed as an alternative to SPSS, it can also open SPSS data formatted data. So it means with the extension SAV. And not only will open rough data, but if you previously applied, or maybe somebody other in SPSS, such procedures such as labeling variables, labeling values, defining missing values, etc., all these properties will be available in Jamovi. So it is not only opening data, but also taking all properties that were already defined in SPSS. That's why maybe this is the best option to open data from SPSS data format, as all necessary steps are already predefined. I will show you also these steps later. So I will open data file, which is called ISSP99CZ .sav, which is prepared for our purposes on shared Google Disk. So this is this ISSP99CZ .sav file. So that's very, very easy and short files with only a selected number of variables, starting from the variable B48, which stands for gender, B7, which are last two digits of your birth, etc., etc. First of all, I will skip to the presentation and some basic information about Jamovi environment. So why Jamovi? So I would say it's a very nice software package. The biggest advantage is it's freeware. It is very quickly developing. And I would say it is very, very nice graphical user interface. So it means that by very simple menus, you can prepare the analysis very easily and nearly in the same style as in SPSS. And also, especially for SPSS users, the big advantage is that Jamovi is very close to SPSS. So it means dialogues in Jamovi looks like SPSS dialogues. So if you're familiar with SPSS, that's very easy to switch into Jamovi, and also just opposite. I would like also to inform you that there is also a competitor, let's call it like this, to Jamovi. This package is called JASP, J-A-S-P, and they are very close to each other. And also I must mention that original developer of JASP left JASP team and then started a Jamovi project. So that's the reason why we have two similar environments. So if you like, you can also use JASP as well. But I must say that at least some properties in Jamovi are slightly better, according to my opinion. So that's why I'm preferring Jamovi to JASP. So here we have first steps. So we will open data. So here it is. And if you like to understand what is behind the data in SPSS, you would be finding a so-called variable view window. Here there is also variable editor. And that's enough only to double click by left button on selected column, and you will change data appearance to variable viewer. So if you double click, for example, to B48, you can directly find this is variable which is discussing gender. You can also find this is variable which is designed here as ordinal. Maybe it's a mistake, gender should be nominal. So let's change it. So you can select here nominal instead of ordinal. And you can also find that these pictures for nominal, ordinal, and continuous variables are all the same as in SPSS environment. The only exception in Jamovi is that it also takes the first type of variable, but it is some technical variable, which is called ID. So you can have some unique identification of the case, which is called ID type of variable. But for us, we would change to nominal. Data type integer means that we have only integers, so no decimal places. And if you like to assign missing values, you can, with no doubt, assign missing values. If you would like to know what is the meaning of individual codes, here you can see male, code 1, and female, code 2. If you would like to change it, or there is no information about value labels, you can assign these labels. The only difference between SPSS and Jamovi in this labeling of individual values is that in SPSS, whatever variable you have, nominal, ordinal, or cardinal, you can assign labels. In Jamovi, and maybe it's a little better option, for cardinal variable, there is no option to assign labels. So if you have cardinal variables, no labels are present here. And last one, but we will show this property later, is to ask for missing values definition. So that's it. And if you like to go to further variables, you can click to this arrow to the right side or left side, and you can select whatever variable you would like to describe. Very easy, I guess. And all necessary properties are present here, according to my opinion. So technical name, variable label, type of variable, missing values, and value labels if your variables are cardinal. If you should take text formatted data, Jamovi would be also capable, but of course, properties such as missing values and levels wouldn't be here. So that's for text formatted data. And if you like to close this dialog, you can click into this arrow up, and once again, you have free data matrix. So that's it, and that's a brief checking of data, and that's brief information about variable properties. I would like only to say, and it could be maybe small unpleasant property of Jamovi environment, that in spite of the fact that, for example, for B48, here it is written gender, but still, if you run some computations, for example, you would like to see frequency table for B48, there would be no description gender, but there would be only description B48. So this is only for you to understand what is the meaning, but it will not be published on output. So let's see how it works, and let's see first output. So you must select analysis here, but still we are here. You must select exploration and descriptives. Descriptives is something like a mixture of frequency tables and descriptives from SPSS. So it can do both of these. So if you run this dialog and open it for the first time, I would say you are like in SPSS. So you can see on the left side, there is a list of all variables that are available. On the right side, you must define at least one variable, and you can also split your results by another variable. So if you take B48 and move to variables, and that's a difference from SPSS, interactively and immediately, your results are here on the right side of your window. So you have two windows separated, not only data previously, but currently here we have input and output in one window. And if you like to see frequency table, you can ask for this. And here you can find frequencies of B48, not frequencies of gender, which would be better. Sorry for that, but that's Jamovi. So that's about label for variable in Jamovi. Once again, it's not present in outputs. Let's go to the next steps, and we will learn basic data transformation. So it means procedures that usually we apply at the beginning of data analysis. And two most common procedures are recoding and computation of new variable. So my proposal is very simple. Let's go back to my data. So let's check once again my data. And let's, for simplicity, first of all, take variable b7. And b7, once again, this is last two digits after 19 of year of birth. You can check that if you double click into this variable, it is written here, it is year of birth. And once again, as data were collected 1999, so for example, 17 means that somebody was born in 1917, 44, 1944, etc. And now my task for computation, it will be my first procedure, could be, okay, I would be happy not to use year of birth, but the age of respondent. So I would like to compute how old was he or she in the year of data collection. So in technical speech, it would be if 17 is year of birth, 1917, and data collection 1999, I would expect that I would take 99 and subtract 17. That would be computation formula. So my proposal is to take B7 and compute 99 minus B7, and I would get age of the respondent as computed variable. New one column in SPSS automatically will be the last one on right-hand side. Here in Jamovi, it depends if you select some column, like I'm here selecting B7, so my new column computed age will be just closest to the B7 to the right, so it will not be last one. But I can also rearrange it and take it as the last one, but we will take it here, so close to B7. So if you like to run computation, you can select, but once again, it's not obligatory column. And then instead of analysis, you must select data here on the main menu. And here there is a dialog for computation. So compute. Here it's necessary to somehow assign new technical name for computed variable. So my proposal is, let's call it age, and be careful. In SPSS, it doesn't matter if you are using big or small letters. They are all the same. In Jamovi, as Jamovi is only graphical interface, by behind the scene there is something that is called R or R project. And in R, everything is case sensitive. So you must differentiate between big and small letters. So if I type age, and next time I will try to use variable age with big letters, it will say, sorry, I don't know such variable. So be careful, and maybe, and that's the easiest style for Jamovi users, they use only small letters, but you can see that in my data is slightly different, so maybe I will use here age in big letters for simplicity. Here you can add, once again, some description. So it means you can say, okay, I would like to describe the age of the respondent in 1999 or something like this. Once again, it will be only here in variable viewer. It will not be present in outputs. And the last one, it is necessary to assign formula. So after this equality sign, you must type the formula. So for my case, 99 minus, and then don't forget to type B with big letter 7. And if you apply this formula, you can see that new one column age is existing here. Here is also some black point, which is saying, okay, it is computed variable. So it's enough to click into enter. And after clicking into enter, you can find directly that age is computed here. So you can check it. 1917, subtracted from 1999, it is 82 years old. Good. 55, 65. Seems that all these procedures are computed properly. Once again, computed column is here described by this black button. If I close this dialog and then maybe save my data, I will show you how it works. Still, every time after reopening this data, you will find that this is computed variable. And if you maybe made some mistake in the computation formula, you can click here into this column once again, left button, double click, and you can change this formula, whatever you would like to change. So that's very, very free and flexible. And once again, for all of you who would reopen data, everybody would have the option to change it. Or maybe you would like maybe also to delete this column. So if you click here on deletion column, it will be deleted from your data. So that's also the option. So that's computed result. And we know that usually if we compute new one column, new one variable, it's every time good to check it. So my proposal is, let's go into analysis, let's go into exploration, descriptives, and let's take this age variable as variable for the computation. And now you can check. The first strange thing would be that for all people, we have year of birth. That's strange. Usually people are not replying sometimes. So we have no missing values. And we can also find that minimum in my data is 0. So somebody who is newborn child is present in my data. That's strange, as my data are about adult population. You can also ask for frequency table to see maybe more, but be careful. If it is computed variable, that's cardinal, and no frequency table is applied here. So at least these zeros are strange and maybe should be omitted from my data. So I can go back to my data. I can double click into age and I can say, oh, that's strange. I made some mistake. And maybe if it is 0, it means that originally in B7, year of birth, there was code 99. And we know that mostly in social sciences, 99 means decay and A. I don't know, no answer. So maybe I made mistake in this computation, and maybe it would be better to go back originally into B7 variable and change 99 into missing. As you can find here in computed variable, there is no space for missing value definition. So you must define properly missing values at the beginning for original variable. So you can go to B7, and you can go to missing values. And here, if you click here to add missing value, you will take 2 equality signs. Sorry for that, but in our language, double equal sign means equality. And if you type 99, those who didn't answer to their year of birth will be omitted from the analysis. So if you click into enter, this condition is applied here, and automatically, and that's maybe advantage, maybe disadvantage of Jamovi, results for age are missing for 6 people, and currently minimum is 18. So seems correct. If it is data representative for adult Czech population, 18 is the youngest people who are adult in the Czech, so seems correct. So once again, if you prepare computed variable, there is no chance to add missing values to computed variable. So it must be computed properly. That's about computation. And now let's choose recoding procedure. Maybe I will continue with the same example. So I will take age, and maybe for simplicity, I would decide to change age into the variable which will be differentiating older and younger people. Only the question is, where would be the border point? So it means where I would divide people into older and younger. So maybe my proposal would be take 50, and people below 50 will be called younger, and 50 plus will be called older. It's up to you to decide, so we can prepare this recoding. Recoding is close to computation. So once again, you need to select data from the menu, and not computation, but it is called generally transformation here. So that's procedure for recoding. So once again, the best is if you select in the first step the variable from which you would like to recode, so age is selected properly, and ask for transformation. Here, the first proposal is that you would be computing variable which is called age number 2. But my proposal is, let's call it age cut, maybe big values, big letters once again. So age cut for simplicity. Recommendation related to Jamovi and other packages, please don't use long names. Ideally, use only 8 symbols maximum, use only English alphabet, use only classical numbers, and from special symbols, use only underline. So age cut still 6 letters, that's good. We can also add some description. And now the question is whether my age category, younger or older, would be nominal, ordinal, etc. We can select it in the next step, but you can select here if it is computed from age or any other variable still. But if we selected age at the beginning, it is automatically computed from age. So I will take age, and now you need to go into using transform option, the last one here, and instead of none, select create new transform. Here, there is new one dialog, which is saying, you can assign some name to transformation. This is always advantageous to use the name for transformation if you're repeatedly using the same transformation rules for more variables. For us, it's nearly useless. I will call it for simplicity recode to have some name. Then you can add your description. Once again, it will be available for you later if you reopen data. And then you would need 2 conditions. If age is below 50 and 50 plus. So you must add one recode condition. First of all, you would get 2 rows. And now you would need to type some logical conditions. So first of all, if $source, and $source means variable age, is below 50. So you would need to select below, lower than, and type 50. And then you must assign some code. So I would propose for simplicity, it will be coded as 1, those who are below 50. And for all other cases, so it means 50 plus, and for simplicity, I would propose use code 0. The easiest variable is 0, 1 coded variable called binary. So if you click into enter, the last one step that I would propose to flow here would be to assign measure type. Jamovi automatically, if it is using transformation for cardinal variable, will create cardinal variable. But according to my opinion, these age categories are maybe nominal, maybe ordinal, so there's some ordering older and younger. But instead of auto, I would select nominal. In Jamovi, and that's the big difference to SPSS, it really matters whether your variable is nominal, ordinal, and cardinal. Let's go back for frequency tables. It is impossible in Jamovi to run frequency table for cardinal variable. So for many procedures in Jamovi, you need to select a proper format measure type of a variable. So here it is. And let's check some first cases. So for example, 82, it is above 49, 50 plus. That's why it is 0. 55, 0. 65, 0. 57, 0. And the first who is below 50 is respondent number 5, who is 40. So that's why the code is 1. The only, once again, unpleasant property of this transform variable, once again, you can see here, red point, which is saying, okay, it is somehow a new variable in my data set. The only unpleasant property is that it is impossible to assign labels. So it is impossible to say 1 is younger, 0 is older. Sorry for that. In Jamovi, if you have recoded data, it's impossible to assign labels. So you must remember. If you would like to see frequency table for HCAT, only to repeat this step: analysis, exploration, descriptives, select HCAT, and ask for frequency tables. And here we have the information that we have here 964 people who are older and 864 who are younger. According to my data, here we have the percentages, and here we have cumulative percentages, but it makes no sense in this data. So that's it. And if you would like to present your data instead of by frequency tables, by some plots, you can, for example, ask for bar plot here, and you would see here absolute figures or counts in bar plots. So that's it. As we have nominal data, no more plots are available here. You can see that other plots that are designed for cardinal or ordinal variables, such as histogram, box plots, are available also here. So that's it. So here we are, and we know how to recode and compute, and we can go to other steps. We know at least a little bit about description of cardinal variable. So if I go back, for example, to my age variable here I have description: number of valid values and missing values, mean, median, standard deviation, minimum, maximum. If I would like to have more or less, I can visit statistics and I can add some of these properties, or I can cancel some of these properties that are present here. I guess quite a lot of options are here. Once again, this descriptives dialog is something like mixture of descriptives and frequencies from SPSS environment. So that's about classical description, and I will only add some information about frequency tables. So if I would run, once again, exploration descriptives and take variable B8, which is the highest achieved education, so I will move it to variables, and ask for frequency tables, I can see the appearance of frequency tables in Jamovi and compare it, for example, to SPSS environment. In SPSS environment, you would get 4 different columns. First one would be counts. Second one would be percentages, including missing cases. Then the next one column will be called valid percentages, excluding missing cases, and then accumulation of percentages, cumulative percentages. In Jamovi, it's slightly different. You can see that we have only counts, percentage for all cases included, and then accumulation. And there is also no total here. For example, information that currently we are proceeding 1,834 respondents is not present here. And I must find previous table, which is present here. Sorry for that, not 34, but 33. One is missing by default. But if you would like to take maybe frequency table for this B8, you would like also to exclude NA. And we know how to proceed such operation. Let's go back to data. Let's select B8, once again, double click by left button. And here you would find that NA option is coded as 99, DK as 88. Only we would like to know what is present in my data. And here we have 1 NA. So we would like to exclude code 99 from my computation. And we know how to proceed this moment. So missing values, click into missing values, add missing value, add true equality sign, and type 99. And once again, as Jamovi is interactive, all outputs automatically will be recomputed. So also this frequency table is not necessary to produce once again as in SPSS, but here NA is missing. So you can find in original table descriptives that not 1, but 2 missing values are currently present. And only 1,832 respondents are valid values. So once again, in SPSS, for frequency tables, you have percentage for all cases and percentage for valid cases only. In Jamovi, it is only for valid cases every time. So it is slightly different. So you need to define missing values properly and use it wisely. So that's about frequency tables in Jamovi. And I guess very quickly, we will go through a couple of statistical procedures from, let's call it, slightly advanced statistics. So first of all, let's take t-tests as classical procedure for comparison of means. Classical two-independent sample t-test is comparing two groups. For analysis of variance, we are comparing more than two groups. So my first proposal is that we would take, for simplicity, variable which is called B41A, which is net monthly personal income. But as you can find only by insight into data matrix, there are a lot of zeros. And usually if we would like to compute mean income, zeros are not welcome. We would be happy if zeros would be omitted. And there is also something like deny to answer, which seems like active option. So first of all, my proposal is to go to B41A and check coding scheme for this variable. First of all, it is defined as ordinal. And the reason why it is defined as ordinal is that it is also associated with some labels. And if there are some labels, in spite of the fact it was originally in SPSS defined as cardinal, Jamovi automatically transfer this variable into ordinal, as if it would transfer into cardinal, these labels wouldn't be here, and you wouldn't be able to recognize what is DKNA, deny to answer, etc. So that's quite advantageous that Jamovi is so intelligent, it can help you. So codes 6 times 8 and 6 times 9 should be omitted, as well as zeros at the beginning. So my proposal is to go to missing values and to define missing value. So add missing value, first of all, is equal to 0. And you can add one more condition. And you can say, okay, if it is greater or equal to 6 times 8, it should be also omitted. Of course, if you like to type 3 conditionals, you can type equality to 6 times 8, equality to 6 times 9. But it is easier to define it by 2 conditions only. If you click into enter, you can find very easily Jamovi style of missing values definition. So they are present here, but they are something like in gray. So these zeros denied to answer are available, but not for computation. So now I guess this variable B41A is prepared for the data analysis, and we can try to answer the question, which is very simple. Is the average income for Czech male and female comparable or not? Male and female variable is the first one we discussed at the beginning. So all t-tests are available, that's not a big surprise, by analysis and t-test option. And if you like to compare 2 groups, such as male and female, that are independent, you can select independent samples t-test. And if you select this dialog, I would say nearly the same as in SPSS. So first of all, B41A variable will be dependent variable. The first one variable in my data set, B48, gender, will be grouping variable. You can find technically that there are some predefined formats, but still accept also ordinal variable. And here we can find the simplest output Jamovi is offering. So students t-test is applied with t-statistics 9.52 and p-value is very low one. So we are rejecting hypothesis that the average for Czech male and female is comparable. But be careful, there is a small note after this small star, and it is written here that Levenes test is significant. So maybe this basic students t-test, which is expecting equal variances, is not the best one option. In Jamovi, it is very easy. You will only replace students test. So here under the list of variable students will be cancelled. And you will ask for worst test, which is classical test for unequal variances. In SPSS, you have automatically both tests available. First one is called equal variances assumed. Second one, unequal variances assumed. Here it is called by names of authors, so it means students test and both test. And current test is correct, and there is no node which is designed here. If you would like to see means in my data, ask for descriptives, and you will see some descriptive statistics, means, median, standard deviations, etc. If you would like to see, for example, I would say nowadays classical output for independent sample t-test, which is coherence D, you can ask for effect size. Here it is, and also for its confidence interval. So you would get 2 more columns, but unfortunately, Jamovi still didn't implement the confidence interval for this Welch test. So if you would like to see confidence interval, you must select students t-test, and here it is present. Sorry for that, but maybe in next version of Jamovi, it will be implemented. So that's how it works in 2 independent samples t-test in Jamovi. And I will show you only a hint, but I will not go into details. If you would be using analysis of variance, you would have more groups. So you would select one-way Anova classically. And here, once again, we can produce the same output. Few groups could be also proceeded here. So income is dependent variable. And let's take once again gender as independent variable. And Jamovi will automatically produce basic Anova table. So it means the test. Once again, p-value is very low one, which is saying for male and female, the average income is not the same. You can add descriptive table for description of your data. And you can also add some post-hoc testing, currently not necessary for my data. You can see that Games Howl for unequal variances is present in a 2K for equal variances present here. So all classical outputs for analysis variance are present here. Only here you have only 2 tests for comparison of groups. In SPSS, you have something like 15 options, but still, I would say nearly the same options as for SPSS. So that's analysis of variance through Jamovi. And now we would run briefly correlations. So to see how we can find relationships for 2 cardinal or 2 ordinal variables. I would say that the dialog is nearly the same as in SPSS. So first of all, I would go into data. And my proposal is, let's take, for example, once again, income variable. We have already defined missing values, so everything is defined properly. And let's, for simplicity, take the closest variable, which is B9. And if I remember properly, B9 is length of education in years. So let's try to find relationship between years of education and personal income. We would expect that maybe the higher the education is, the higher income is. So there would be some positive relationship. Only we need to check if for years of education, once again, it's incorrectly defined as ordinal variable, if there is no special code, and here it is, DKNA 88. So that's why it is defined as ordinal. As if it would be defined as cardinal, no labeling would be present here, and it would be for us impossible to recognize. We should define 88 as missing value. So my proposal is, let's go once again into missing values and define missing values equal to 88. And if I run this dialog, both variables are prepared for data analysis. Once again, we would be correlating length of education and monthly income in Czech crowns. So once again, let's go into analysis. And correlations are hidden under regression umbrella. So you select regression. And here we have, if you would like to find correlation between 2 variables, correlation matrix. So you would select correlation matrix and select B41A and B9. So take it as it is. And automatically, as you can see, Jamovi is computing results. So automatically, Jamovi is computing Pearson's correlation coefficient, which is designed for cardinal data. But in spite of the fact that both variables here are, according to Jamovi, ordinal, they are both cardinal by their properties. So that's correct. If you would like to compute Spearman or Kendall, you can select these formulas. You can see that this is default output, so it means correlation coefficient, degrees of freedom, and p-value. If the p-value once again is low one, it means there is some relationship between income and education also in the population to which we are inferring from our sample. If you would like to have more, you can ask for confidence interval. So you can try to find the estimated value of correlation coefficient in the overall population. So here it is, confidence interval from lower to upper. That's quite strange that upper is above lower, but still present here. And you can also ask for plot. So if you like to have plot for your data, so you can ask for so-called correlation matrix. And you can also add densities for variables and the level of correlation into one picture. So this is somehow combined picture. Relationship is here on the left bottom part of this dialog. Here are densities for both variables, and here we have correlation coefficient with statistical evaluation. So that's correlation in Jamovi environment, very simple. If you would like to take correlation for two variables and controlling other, we call it partial, we would need to visit regression and partial correlation dialog. Once again, nearly the same as in SPSS. And last one procedure for today related to classical statistical approaches is contingency table analysis. So it means if you would like, for example, to combine variables that are nominal and ordinal together and find their relationships. I must say that for contingency tables, Jamovi will not offer so many options as SPSS, sorry for that, but maybe that future versions will be better, but still some basic options are available. So my proposal for simplicity is to take a variable for gender, B48, and combine it with a variable B1. So I will show what is the meaning of B1 variable. And you can find that B1 variable is whether he or she participated in the last election. Answers were yes, no, he or she didn't have right to vote. So three options. So we would prepare the table, which would be called 2 × 3 contingency table. So my proposal is that it's not necessary to prepare data somehow. All options are prepared for data analysis. So we can go quickly into analysis. And procedures for nominal and ordinal data in Jamovi are called frequencies. So if you would like to run procedures that are designed specially for ordinal and nominal data, visit frequencies. You can go to frequencies and contingency table classical analysis is hidden by contingency tables and independent samples chi-square test of association. That's what would be called in SPSS cross steps or cross tabulations. This is the same story. So if you open the dialog, I would say nearly the same as in SPSS. Row and column variable must be defined at least. And then you can define layers, or you can define also count variable, but not necessary for us. My proposal would be, let's create rows by gender, B48, and B1 would create columns. And you would get very simply, by default, contingency table in counts. So you can see how many people are for different combinations, whether I'm male, female, I voted, didn't vote, or didn't have right to vote. You can also find that total number of respondents is 1,834 for the analysis. And there is also p-value associated to chi-square test of independence. If you select to read out this p-value, as it is quite big one, we were not able to prove relationship between gender and voting participation. But usually instead of these counts, so it means observed frequencies, we would maybe like to replace these by some percentages. So if you like to replace these counts or observed counts by percentages, you can go into cells on the left-hand side dialog, and ideally maybe row percentages would be nice to see how many of male and female respondent percentages were voting, etc., etc. So I would ask for row, and I would cancel observed counts, as maybe it is always useful to have only one information. So you can find that currently there is description. These are percentages within row. So it must be that total in one row must be 100. That's control. And you can find that for male, there were 72.3 those who were voting. 27.6 didn't vote, and 0.1 in percentages didn't have right to vote. And for women, the pattern is very similar. And that's why test at the end, so it means this p-value associated to chi-square test of independence is saying, okay, seems to me that maybe in your data, there is some minor difference, but maybe in the population, there will be no difference at all in the percentage of those who voted and didn't vote. If you like to present your results, and that's slightly different from SPSS, not by tables, but by plots, you can ask for plots here. And here you can ask for bar plot. And you can only exchange your values, so it means observed counts, into percentages. And if I select once again within row percentages, here we have the table which is present in bar plot. So you can see that these proportions of blue and gray, these that are orange cannot be seen here. They are very small one, are very close to each other. So once again, the same pattern as we discussed by previous data analysis by chi-square test. And once again, very similar to SPSS style, there is option which is called statistics. And here you can ask for chi-square test, which is default. You can also choose likelihood ratio test, which is sometimes better. For small data files, you can apply Fisher's exact test. And you can also apply for two tables only, odds ratio and log odds ratio, relative risk, and other descriptives. And if you like to measure relationship between variables, so here you have for nominal variables, classical contingency coefficient, which was originated by Pearson, or I would say something like classic in current times, which is Kramer's V. So if you ask for Kramer's V, you will find it is 0.04, very small one. So no relationship between data. For phi coefficient, you can see NaN, as this coefficient is available only for 2 times 2 tables. So that's why for tables it's not available. And if your data are ordinal, you have here gamma coefficient, Kendall-Stau, and Mental-Hansel measurement of relationship. So that's all about contingency tables through Jamovi. And before we finish our today's session, I would like only to say something more about usage of outputs and about data and all results in Jamovi. So first one comment is related to these outputs. So if you would like to take individual table or individual chart, it's enough to click by right button, and you can easily copy and paste, for example, into Microsoft Excel environment, Microsoft Word environment, etc. So I will, for simplicity, open Microsoft Excel environment to see how it works. And you can copy the table, and in spite of the fact this is quite small one, you can find this is the same table, only there are some sparse rows, columns present here that should be maybe omitted. But it is copied, and all necessary output is present for you. So you can copy paste with no problem at all. If you copy table, it could be edited. If you copy chart, it's only image, so you cannot change it. If you are finishing your work with Jamovi, you can save all this work together. So it means you will save data and all properties you assign to individual variables. You will also assign all these inputs and all these outputs into one file. That's totally different from SPSS. Remember that in SPSS, you are saving data separately, saving outputs, if you make some commands, you are also saving commands. So you will have 3 separated files. Here, under one umbrella, all will be together. So it means data with all changes, analysis, so it means all inputs, and all outputs, so it means all produced tables and all produced charts. And if you would like to save it all and reopen next time and work with this, you would go to this left upper corner, 3 lines, and take Save As. And then you can select the folder you would wish to save. Automatically, Jamovi will assign the extension OMV, that's internal extension for Jamovi files. And automatically, it will also give the same name as was the name of the file we just opened. So if you would like to name it by another way, for example, Jamovi, you would type Jamovi, and it would be jamovi.extension OMV. And if you save it, it will be prepared for next session. So if you open it next time, it will be available with all these data, their properties, inputs, and outputs. Last comment to these outputs in Jamovi. Sometimes it is useful, especially if you're saving this Jamovi internal format, that you would add some comment to your output. So if you click by right button into individual output, you can copy, export, but you can also add node. So if you click into add node option, you can type whatever you want. So it means some interpretation or some node, what is the meaning of your output. So also these nodes, if you save your Jamovi file, will be after reopening available to all of you. So that's, I guess, from my side, all about Jamovi. If you like to know more, ask me. And of course, you can learn more from Jamovi webpage. There is also some official YouTube channel on Jamovi, etc., etc. So it's up to learn more, but I guess that this environment is very easy and understandable to use.